Hi everybody, this is the activity we did in class today, and what you see are these two platforms that we've talked about before. This is our metal one that is a conductor. This is our non-metal one, which is an insulator, and you can see I've got right on the corners of here some surface temperature thermometers attached to them, and that's what you see on the left. And I'm going to go ahead and start those thermometers right now, and what I'm going to do is I'm going to put ice cubes on each of these two surfaces. And we're going to watch not only what happens to the ice cubes, but we're also going to watch what happens to the temperature of the blocks as the ice cubes are put on. So I'm going to go ahead and put them on. And as you can see on the video, the one on the right, which is our conductor, the ice cube is melting almost immediately. You can even see the puddle of water that's off to the side of it right now. And the other thing that you can see on the left is that the temperature of the block that the ice cube is melting on is actually dropping way down, because the red line is the temperature of the block on the right that is melting. And that's a very counterintuitive kind of thing, to think that the ice cube is melting faster on the colder surface, until we think about why that may be. Why would an ice cube melt faster on a colder surface? And the key is, if it's getting colder, then heat has got to be leaving the block. And the key is, well, where is the heat that's leaving the block that's making it colder going? And hot is going to cold, and that heat is going directly into the ice cube. And that's what's melting the ice cube. So we have this very counterintuitive kind of thing where we have this colder surface that's melting the ice cube quicker. But remember, that metal is a conductor, which means it moves its heat real easily. The ice cube on the left is on an insulator. It can't move its heat very easily. You can see the blue line has maybe dropped just a little bit, but it is not able to move its heat into the ice cube nearly as quickly or as well, because it's an insulator. The one on the right, again, is our conductor, moves heat really well, and in this case it's moving heat out of itself and directly into the ice cube. And since the ice cube is getting that additional heat, you can see it is melting much, much faster. And this activity is one of my favorites we do, and it's one of my favorites because it just deals with a lot of different aspects of heat that we've been talking about. Clearly, we have hot going to cold. We have hot going to cold via conduction. We have an object losing heat, and so it's getting colder, just like we saw in all of our amplify situations. So what you need to do now is you need to download the document and fill in all of the blanks. And it really covers almost everything we've been talking about the last couple of weeks. This is really a kind of review kind of activity that uses parts of all of what we've done. And I'm not going to keep playing this any longer, but if this stayed up here for another couple of minutes, that ice cube would be completely melted. At any rate, thank you for watching.